Picture this, it is 2 a.m. A file of yesterday's orders quietly lands in a cloud bucket. Nobody is awake. By the time your team logs in, the revenue dashboard is already fresh. That is not magic, that is a pipeline. In this lesson, you build one, start to finish on Databricks. Every single line is copy and paste ready. This is the exact medallion pattern real teams run in production. By the end, you will have a working incremental monitored pipeline and you can adapt it Monday morning to your own data. Let me show you the whole shape first. Take a look at the entire pipeline in one picture files land in cloud storage. Autoloader picks them up. They flow into bronze, then silver, then gold. That is the medallion pattern and it is the backbone of everything we build today. Here is the simplest way to hold it in your head. Bronze is raw, exactly as it landed. Silver is typed and deduplicated. Gold is the business aggregate your dashboard reads. And wrapping all three, a Databricks job orchestrates and schedules the whole flow. 3 layers, one job. Now let us ground it in a real example. Imagine you run analytics for an online store. Every night around 2 a.m., a daily orders file drops into a cloud storage folder. Your goal is simple to say and tricky to do well. A clean, deduplicated gold table of daily revenue. Feeding a sales dashboard. Here is the beautiful part. You build this pipeline exactly once. Then a job runs it every single morning on its own and it runs incrementally touching only the new file, not the whole history. Build once, run forever. So why autoloader and why delta? Let us answer that next. Let me explain the two core choices behind this design. First, how do files arrive autoloader? The cloud file source incrementally picks up only the new files. No manual lists, no tracking which file you already loaded. It remembers for you. Second, why store in Delta? Delta gives you a CID transactions, schema enforcement and time travel all on plain cloud storage. And here is the rule that saves you. Always land raw to bronze first, then transform downstream. That keeps everything rerunable. A bad transform never touches your raw data. Now let us look closer at those 3 layers. Think of these 3 layers like a professional kitchen. Bronze is the receiving dock. It is exactly what arrived plus a little ingest metadata. You never edit it, it is your source of truth. Silver is the prep station. Typed, deduplicated, nulls handled, everything conformed and clean. Gold is the plated dish. Business ready aggregates that go straight to the dashboard. Dock prep counter, plated meal. Raw comes in one end, polished inside comes out the other. With the map clear, let us start writing the actual pipeline. Step 1 is setting up where you read from and where you track progress. Read your source files from a governed location. That means a Unity catalog volume or an external location, never embedded keys in your code. Then pick a checkpoint path for the stream. Checkpoints store the ingest progress and the offsets. So the stream knows what it already read. And here is the gotcha that trips people up. Each autoloader stream needs its own checkpoint location. Never share one between streams. Share a checkpoint and you corrupt both. With paths in place, let us read those files. Step 2 is where autoloader earns its keep. You call spark.readStream with format set to cloud files. Then the option cloudfiles.format tells it whether the files are CSV, JSON or Parquet. Next, cloudfiles.schema location. This lets autoloader infer the schema and remember it across every run. And here is the part that makes your life easy. It ingests only files it has not seen before. No manual bookkeeping of what loaded and what did not. It just knows. Now we write that stream into our bronze table. Step 3 writes everything into bronze with a safety net. You call write stream into a delta table and you set the checkpoint location option to the path you chose. While you are at it, add a little lineage. Stamp each row with current timestamp and the source file name so you always know where data came from. Now the clever bit for a daily job, trigger with available now set to true. It processes all the waiting files once, then it stops. That is perfect for a scheduled morning run. Process then sleep. Let us confirm the data actually landed. Before you transform anything, verify the load run a simple select count star from main.sales.orders bronze. Does that number match the files you dropped in? If it does, take a second to enjoy it. You just incrementally ingested real data into a delta table. That is a quick win. But make this a habit, not a one-time celebration. Always validate your counts before you transform. Trust nothing silently. A 5-second count check saves a 5-hour debug later. Speaking of surprises, what happens when the source changes its shape? Let me hit a real world worry head on. What if the source adds a new column tomorrow? By default, many pipelines silently drop it and you lose data without knowing. Autoloader can detect it instead. Set cloudfiles.schema evolution mode to add new columns. Now new fields get added as they appear. Here is the one gotcha to expect. On a schema change, the stream may stop just so the change gets recorded properly. It resumes on restart and your job picks it right back up. A brief pause, not a data loss. Now let us turn raw bronze into clean silver. Step 4, reshapes bronze into a clean silver table. Here you do three things. Cast the types so a number is a number and a date is a date. Coalesce the nulls so missing values do not poison your math. And deduplicate using row number over partition by order ID, ordered by ingested at descending. That keeps only the latest version of each order. Then you write that type deduplicated result to a silver delta table. And notice what you did not touch. Bronze stays exactly as it was. Rerun this transform anytime completely safely. But how you write silver matters enormously. Let me show you the wrong way first. Let me warn you about a trap I see constantly. The wrong way is to rebuild the whole table on every run. Create or replace table across the full history every single morning. Here's why it breaks. You reprocess years of data just to add one new day. Cost and runtime grow forever and they never come back down. Worse, anyone reading the table sees it churn underneath them. The right way is to merge only the change keys into silver. An idempotent incremental upset, small, fast and safe to repeat. Let us write that merge now. Step 5 is the incremental heart of the whole pipeline. You write merge into order silver using the new batch matching on order ID. When a row matches, you update it. When it does not match, you insert it, and here is the property that makes you sleep at night. Rerunning the same data is completely safe. Matched rows just update in place, and you get zero duplicates. That word idempotent simply means you can run it twice and the result is identical. Touch only what changed, never the whole table, with silver clean and incremental. Gold is the easy part. Step 6 builds the gold aggregate your dashboard actually reads. Create or replace table gold daily sales as a select that groups by order date. Sum the amount as revenue. Count the rows as orders. And that is it. This is what your BI tool connects to small, fast and shaped like the business question. One row per day, revenue and order count. Nothing more. Keep gold narrow and pre-aggregated. That is what keeps dashboards fast and cheap. A skinny gold table is a happy dashboard. Now we have all the pieces, let us wire them together. Take a look at how a Databricks job chains everything together. A job links tasks in order. Ingest bronze runs first, then build silver, then build gold. Each task depends on the one before it, so they never run out of order. Then you add a schedule, say daily at 6 am. Now the file that landed at 2 am gets processed automatically with nobody awake. Each task is just a notebook or a script. The job is the DAG that wires them together and runs them. And a real job needs eyes on it. Let us talk operations. Running a pipeline is not finished when it runs once. It is finished when it runs reliably at 2 am without you. The job run history shows each task's status, duration and logs. That is your first stop the moment something breaks. Set per task retries so a transient hiccup just tries again. And add a failure notification, an email or a webhook. That way, a 2 am failure actually pages someone. One more tool, describe history on any delta table, shows every commit. You can audit and debug straight from the transaction log. Now let us talk about the choices that affect your bill. Let me walk you through a trade-off that hits your wallet. For a daily file, available now is the smart choice. It behaves like a batch. The job wakes it, it runs, it stops. That is cheap. Always on streaming gives you lower latency but at much higher cost. Match the choice to the need. Same idea for compute, serverless or job cluster spin up per run and shut right down. A busty daily pipeline should never sit on an idle all-purpose cluster. An idle cluster left running is the classic silent cost leak. Match your compute to the workload always. Now, when things do go wrong, where do you look? Let me give you a quick field guide for when a run fails. Seeing a schema mismatch. Check the rescue data column and the schema location. The source probably changed its shape on you. Finding duplicate rows downstream. Your dedup or merge key is wrong. Fix the key, then reprocess from bronze because bronze still has the truth. Pipeline stuck or suddenly reprocessing everything. That is almost always a deleted or wrong checkpoint. The stream forgot where it was. 3 symptoms, 3 suspects. Let us pull the whole build onto one card. This slide is the whole pipeline on a single card. Screenshot it. Storage into autoloader with cloud files into bronze. Then transform and deduct into silver with a merge to keep it incremental. Then aggregate into gold and a scheduled job wires the entire thing together. Here are the 4 rules to remember. Bronze is immutable. Transforms are rerunable. Merge is idempotent. And the job schedules and monitors. That is the complete build end to end in 6 steps. Keep this card. Now let us turn it into an interview answer. Let me hand you a polished answer for a very common interview question. How would you build a Databricks pipeline? Answer in 6 beats. Autoloader ingest, delta bronze with a checkpoint, typed silver, idempotent merge, gold aggregate, and a scheduled job. Then say the why, because that is what separates you. Immutable bronze rerundable transforms, idempotent upserts, monitored and alerted. Finish with the trade off. Available now for a daily file, streaming for low latency. That one line signals you have actually shipped this, not just read about it. And you really have. Let us wrap up. We just built a complete production shaped Databricks pipeline together. Cloud files flowing into a scheduled goal table. The exact medallion pattern you can adapt to any source on Monday morning. You ingested with autoloader, layered bronze, silver and gold, made it incremental with merge and wrapped it in a monitor job. Want to go deeper? The full Databricks course linked below takes you hands-on with clusters, Delta jobs and Unity catalog. Subscribe for the streaming cost and Delta deep dives coming next. So tell me, what is your data source? Drop it in the comments.